Hi there, we're going to do swap nodes in pairs. So let's understand this problem and come up with a solution. So here we are, 1 points to 2, points to 3, points to 4. And what we want in the output is 2 points to 1, points to 4, points to 3. So how do we do that? Well, first of all, we know we need a dummy node to point to our first item. Okay, so let's create a dummy node and point everything to that. So we can start swapping. Because if that's the head node, we can't do anything about it. So first things first, let's talk about match. We need a dummy node. Second, we need a past, previous, and a current node. Okay, and we're just going to swap every other node. And I think we might need a next node because we need to know what the next item is. So with that, let's see how we can swap these items after we come up with a couple of edge cases. So cases, and we have this input and output, pretty normal. And let's talk about edge cases. So what happens if there are 3 items, right? If there are 3 items, do we swap the last one? Let's see. You may solve about modifying, swap. What happens when you have the 3 items? We don't swap a single item, of course, but we don't know the edge case. Exactly what happens when you have 3 items. We can have 0 to 100 items. So I mean, with a dummy node, I believe we can take care of these last 2 cases easily. So but our only problem is what exactly happens when we have 1, 2, 3 instead of 1, 2, 3, 4. Do we just stop? We just go 2, 1, 3? Let's find out. And that's pretty easy to find out with this because we just have to return well, that's not that easy. So list node at 2 dummy equals list node dot dummy dot next equals list node of 1, dummy equals dummy dot next, and dummy dot next is equal to list node at 3. Okay, and return dummy. Perfect. Okay, let's check it out. 3 items. And hopefully that this is exactly what we assume to. So, okay. 2. Right. That was funny. But yes, we're going to return a 213. That's what we want to return. Actually, we don't actually need to create this code. It looks like it will just return, give us our expected output immediately down below. So, okay, with that, we do a dummy node, and we need several pointers. Okay, let's have a plan. Okay, so we have a previous, and we just have to repeat the process until basically a time at which this needs to end. So it looks like in this case we have a previous which will point to our new item, and what we're going to do is just produce multiple images of the next steps that we have. And so currently, we want to be able to point 1 to 3 and 2 to 1. Okay, so I mean, easiest way is create next, but that seems to be rather, pushing it. I'm not sure if that's the right method. Of course, there's no right method, but I mean, we're pushing along as we speak. So let's try setting next to equal to dot next equals to current. So we're gonna swap this. And now current dot next is equal to next. So this will point to next, point to 3. And next dot next equals, well, if it's set to current, that means this pointer is gone. And now we have a 1 pointing to a 3. So we have 2, 1, and then 3. The dummy node now needs to point to next. So previous is equal dot next is equal to next. Okay, with that operation, what happens is that we have a brand new image. And I don't know if it's going to take us anywhere, but I mean, we have to find out. So let's rearrange everything so that, and then we set previous.next is equal to 2, right? And there should be one more thing we need to do. Where's the next previous item? Don't know yet, but we're going to have to move everything around. So it doesn't matter what the pointers are below. But we'll have to start moving things around. So we have a 2 here pointing to a 1 and 1 pointing to a 3. Currently, the current is at 1 and next is at 2. Next is still at 3. Okay. And so all the items are all mixed up and it's 2, 1, 3 at this point. And where do we need to move the previous? The previous needs to move to the current. And the current needs to be moved to current.next. And next is equal to next. And this none points to like none here, right? And so we repeat the process of next.next is 3, so it's no longer none. So 4 points to 3. And 3 now points to next, so points to none. So it points to the next item, none. And so it looks like we do need a while next if the next exists, current.next exists. If the current.next does not exist, then we can end the loop. So we can do a while current.next. Okay, or just while next exist. Okay, so we have the pointers and we point previous next equals next. So basically what happens in this picture is everything gets reorganized to this becomes a 4, right? And that points to a 3, which points to none. And yeah, and then we shift everything forward. So previous is equal to current, and then we create current while current and current.next. So while current, I mean, if current's none, then we can return at this point. So we do need a couple items, and yeah, that's it. That's all we need to do. Okay, so with that, I think we came up with the plan. That was our plan, yes. So the plan was to shift these pointers around. And while this is happening, so I basically wrote code essentially for my plan. But I think for this type of problem, I think words are more clear than, I mean, code is more clear than words when you're working with linked lists. All right, let's just implement it. Okay, so let's set our previous is equal to, previous is equal to dummy node, which is equal to list node, a brand new list node. And let's just create that. The next val equals 0, and we could set it to D actually. And next node is equal to our head. And so, well, current equals previous dot next, and current equals current dot next. Oh, shoot, my bad. I mean next. And the question is, do we need to generate the next dot next? I don't think so. All right. So also another question, will we run out of bounds when we ask for, I mean, current equals previous dot next, and when there's no head? I mean, surely, yeah, it will cause a problem when we ask for next. So I don't think that's a good idea. So we do need to think of how to handle that. And I think that we should just cut it off right here at previous dot next, get the cur, because we know for sure previous dot next does exist. It could be none. So while cur, we can look at the next item, right? Okay, so while current, and now we can generate our next items. So next is equal to current dot next, so that must exist. But we don't know for sure if next dot next exists, because if you look at like one item, 2 items, that could be an issue. Like let's say yeah, this is a lot of edge cases at this point. So previous, current, and current dot next. That's fine. That's fine. And when we push everything forward, is that fine as well? Yeah, it's fine. I think it's fine. It looks everything looks fine. Okay, let's just do it. So return dummy node dot next. Okay, so let's just get started. Next is equal to next dot next. I mean, suppose that we have a single item. What happens then, right? That will definitely go out of bounds, right? Yeah, that would go out of bounds. And so that will prevent the problem. If current and current dot next, then, well, this will not run at all and we'll just return 2. Perfect. But if there is a 1, right, and it does exist, that means we do need to flip it, and we are ready to flip that. And when next dot next is being none is perfectly fine. So that's great. So that we are doing. So now we have all our variables, and we can now get next, and we just need next is equal to cur, and cur.next is equal to next, and previous.next is equal to next. And now we need to reset our previous and our current. So previous is now equal to current, and current is now equal to current dot next. And how do we do all of this? That was on the plan, all in the plan. So with that, we should be good to go. And if we need any debugging, we'll debug it later. Okay, so let's just run the code. We have some unexpected indentation at this point on line 55. Okay, and let's just use example test cases and run it. We have another unexpected line on line 62. Let's run it again. Run it again. And everything has been accepted perfectly. And let's try a test case where we have 3 items. Run the code. And it looks good. Let's submit it. All right, looks like it worked perfectly fine. And as we have reviewed earlier how that worked, we reviewed the code already, and done. It was done. And now we just do evaluation, how that works. The evaluation is to evaluate. We did an O of n operation on all the items, time, and we need a space is just O of 1. Because we did basically use pointers. So because pointer and because goes through each node. Okay, that's it. Let's run it one more time just because, I mean, it's kind of slow for some reason. I think this is as, yeah, I mean, well, it is what it is. Well, with that, I think people might be using something that's much more memory intensive to do this. I don't know how they're doing it, but this is how we solved it. If you enjoyed this video, like and subscribe. Want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.